The target variable is the thrust of a jet turbine engine, and the possible predictors are primary speed of rotation, secondary speed of rotation, fuel flow rate, pressure, exhaust temperature, and ambient temperature at the time of the test. We started off with x1 through x6, and in the first step I removed x2 as it had the highest p-value and that value was above alpha. Next I removed x4 for the same reason, and I finally removed x5 also for the same reason. At this point, all of the p-values for each variable were less than alpha. The overall f significance was also less than alpha. There were only 2 standardized residuals that were not within plus or minus 2 standard deviations. Therefore, 95% of the 40 data points fell within the plus or minus 2 range. And finally, all of the residual plots were acceptable as there were not patterns or shapes, but rather the graphs looked like swarms of bees. For my final model, the following variables were chosen: x1, the primary speed of rotation, x3, the fuel flow rate, and x6, the ambient temperature at the time of the test. My final regression equation was thrust of a jet turbine engine equals negative 7,028 plus 1.36 times the primary speed of rotation plus 0.34 times the fuel flow rate minus 17.85 times the ambient temperature at the time of the test. This regression equation predicts that thrust starts out at negative 7,028, and for every 1 unit increase in primary speed of rotation, the thrust increases by 1.36. For every 1 unit increase in fuel flow rate, the thrust increases by 0.34, and for every 1 unit increase in ambient temperature, the thrust decreases by 17.85. Substituting the given values for x1, x3, and x6, I predicted the thrust to be 4,107.